Hello everybody, this is Luca Fontana and this is the second episode for the second series of ConveyorU. We are recording this video at a very late evening, Friday late evening. We had very busy weeks. And we will be discussing today about another very important topic. It's production batches. Okay, so this topic is particularly important to understand because it's a rather small issue, but can create big problems if it's not understood well and dealt with. Production batches goes back to the concept of product pacing. So if you remember, we discussed the concept of product pacing, and particularly about regular product pacing, when we were discussing the basic topic of the speed of the conveyors. So we know that the regular nominal speed of the conveyor is when all the products are close one to the other, and that the standard speed for designing a conveyor is when the products are evenly paced on a conveyor and at a speed that is 1.5 to 2 times the nominal speed of the conveyor. So this will mean that if we are running at twice the nominal speed, the product will show themselves as one product, a blank hole of the size of the product, and another product. Okay, so this is the regular pacing. So the regular pacing is the ideal condition to have a conveyor running. But it's not always the case. We may have a number of situations why we will see products getting close one to the other, even if the speed remains higher than the nominal one. Okay, so for example, maybe we have a pneumatic stop on the conveyor, or maybe one of the machines that feed the conveyor deliver the product in small batches. So a batch of product is basically a train of products all coming one close to the other, and the conveyor will be running at a higher speed than the nominal one. So what will happen is that this small train of product will be running all together, then there will be a big hole on the conveyor, and then there will be another train. Okay, so this situation it can create lots of problems, because even if the average production rate that we will see on the conveyor is exactly the same as we would have if the pacing of the products is regular on the conveyor, the instant production rate that a downstream machine or a pick-and-place robot we will see when the train of products arrive at a higher speed, it may be double or even 3 times the regular pacing of the product. So for example, let's say that we have a line that is running at 60 products per minute. Okay, so each second one product arrives, and we have a robot that can pick this product up, and it can do it without any problem if the products are regularly paced on the conveyor. So let's say that we are running at 2 times the nominal speed, so there is one product, one hole of the size of one product, and then another product, and so on and so forth. So when the product arrives under the hand of the robot has 0.5 seconds to pick the product up, okay, and then it has another 0.5 seconds to place the products on maybe a tray or something like that. Okay, but when we have the conveyor still running at the same speed, so twice the nominal speed, and the products are arriving in a train all together, now the robot does not have any time between the picking up of the product and the second product arriving under the picking position. So the product will always have its 0.5 seconds to pick the product up, but it will not have the 0.5 second to place the product on the tray, because the second product of the train is already there and it has no place to go, because then comes immediately a third product of the train, and so on and so forth. Okay, so this means that the instant speed, the speed that the machine sees, sorry, not the speed, but the production rate that the machine sees, it's actually double or even more than the nominal one. Okay, so in some way this situation must be dealt with, must be regularized. Okay, so we may have three different basically situations. The most easy one is that the product cannot accumulate, so it's a regular shape, rather rigid product, and the machine downstream will work with a minimum load. Okay, so you can place an accumulating conveyor with the products all touching one against the other before the machine downstream, and the machine itself will be able to phase the product and load inside the machine without adding anything else to do, rather than slowing down all the conveyors to the nominal speed. Okay, the other situation, rather it is easy one too, is that the product can accumulate. Okay, so as we said, regular shape, rigid product, and the machine downstream cannot load the product in accumulation. It doesn't have a minimum load. Okay, but in this case we can do it. We can deal with this very easily. All we will need to do is to place yet again another accumulation conveyor running at the nominal speed. So when the train of product will arrive at double the speed, they will slow down, possibly sliding on the accumulating conveyor, and when the other train arrives, it will immediately close the gap that it has with the train before, because the accumulating conveyor is running at exactly the nominal speed. Okay, so on this accumulating conveyor we'll have all the products touching one against the other, and to regularize the pace, all that we need to do in this case, it's very simple. We just need to place an accelerating conveyor after the accumulating one. So we will have the accumulating conveyor running at the nominal speed. We will have a very small accelerating conveyor after this one, running at twice the nominal speed. So once the first product of the train reaches and passes from the accumulating conveyor to the accelerating one, this will immediately create the gap that we need. So this allows us to rephase the product, regularize the pacing of the products in a very easy way. Now things get much more complicated when products cannot accumulate. Okay, so flow wraps, soft products, naked products, whatever it is. You remember the previous posting about accumulation. Okay, so in this case, if we have a train of products, because the upstream machine sent us a train of product, and then we have a big hole, the only way we have to regularize this is to use a very high grip conveyor and use a sensor that read the arrival of the first product on the high grip conveyor, and as soon as it reads the arrival of the product, it will immediately accelerate in order to make a certain distance, the pace that we want to achieve. So this conveyor will need, other than the photocell to read the arrival of the product, we will need a special kind of motor, like a step motor or a brushless drive or something like that. Depending on the lightness and friction between the product and the belt, we may have also to add a blower to have vacuum suction and keep the product from sliding on the conveyor while this one accelerates. So basically what we do is we read the arrival of the product, and make one pace and then wait if there is nothing else. And if there is immediately another product, we create another pace. And so this will go on as long as we have products arriving, and we will make a pace which is a little bit higher than the length of the product. But as soon as the product stops to arriving, so we get the gap before the other train, the conveyor stops. So this will allow to create a regular pacing, and when the products leave this pacing conveyor after reaching the other one that will connect to the downstream machine, now the pacing will be regularized and the speed will be regularized. So for the downstream machine, the products will again will be arriving at the nominal production rate and not at the higher one. Okay, so this is really demonstrates how a small issue can create huge problems of efficiency in a packaging line. Particularly in this last most difficult situation, we are adding a sensor, we are adding a brushless or a step motor, we are adding some software engineering in the PLC. This means that there are several thousands of euros to solve what seems to be really a small issue of distance between the products. So this is the demonstration on how carefully a conveyor line must be designed to avoid jeopardizing the efficiency of high-value packaging machines. Once again, project engineering need to take this information in great care and remember it when connecting together different machines. Always to ask to the supplier of the machine how they will deliver the product and how they will need to be fed. Thanks for listening, thanks for watching, and see you the next time with the new episode of ConveyorU. Bye.